Let's break down the time estimates for the outdoor electrical work. First, we will discuss the outside receptacles and home run. The estimate for fishing the wire is 1 IO per outlet times 3 outlets, which equals 3 hours. Connecting to the panel is estimated at 1 hour. The total estimated time for the outside receptacles and home run is 4 hours. Secondly, we can consider the ceiling fans and fish taps. The estimate for fishing the wire is 30 minutes per tap times 4 taps, which equals 2 hours. Connecting to fans and receptacles is estimated at 1 hour. Therefore, the total time estimate for the ceiling fans and fish taps is 3 hours. Finally, we can consider the outside light replacement. Removing the old lights is estimated at 30 minutes. Installing the new lights is estimated at 30 minutes. This means the total time estimate for the outside light replacement is 1 hour. This brings us to a total time estimate of 8 hours. Now, let's compare this to your time estimate. Your time estimate is 9 hours. Your time estimate of 9 hours is slightly higher than the estimate of 8 hours. This may be due to factors such as the difficulty of fishing the wire, the complexity of the connections, or the need for additional troubleshooting. Here are some possible time-saving measures you can consider. Firstly, if possible, use a fish tape to pull the wire instead of manually feeding it. Secondly, use pre-wired fans to save time on connections. Thirdly, test the connections thoroughly before closing up the walls or ceilings. Overall, your time estimate is reasonable, although you may be able to save some time by using more efficient techniques. When planning any electrical work, always prioritize safety and adhere to local electrical codes. If you are not comfortable performing the work yourself, it is always best to hire a qualified electrician. Remember to de-energize the circuit before starting any work and use appropriate personal protective equipment such as gloves and safety glasses. Always double-check your connections and ensure that all wires are properly secured. Consider the specific challenges of each task. Fishing wires through tight spaces or working at heights can take more time than anticipated. Weather conditions can also affect the time required for outdoor work. Factor in time for breaks and unexpected delays. It is always better to overestimate the time required than to underestimate it. This can help you avoid rushing and ensure that the job is done safely and correctly. When running a new circuit, ensure that the wire gauge is appropriate for the load. Consult the National Electrical Code, or NEC Table 310.15b16 for ampacity ratings of conductors. Use the correct size breaker for the circuit to protect against overloads and short circuits. When installing outdoor receptacles, use weatherproof boxes and covers to protect against moisture. Ground fault circuit interrupter, or GFCI, protection is required for all outdoor receptacles. When installing ceiling fans, ensure that the mounting box is rated for the weight of the fan. Use a fan-rated support brace if necessary. When replacing lights, use energy-efficient light-emitting diode or LED bulbs to save energy. Consider using a voltage tester to verify that the circuit is de-energized before starting work. Use wire connectors that are appropriate for the wire size and type. Make sure all connections are tight and secure. When fishing wires, use a fish tape or wire snake to help guide the wire through walls and ceilings. Lubricate the wire with wire pulling lubricant to reduce friction. When working at heights, use a ladder that is in good condition and is placed on a stable surface. Have someone spot you while you are working on the ladder. Wear appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and a hard hat. Keep your work area clean and organized. This will help you avoid accidents and make it easier to find the tools and materials you need. Take your time and do the job right the first time. This will save you time and money in the long run. Consider using a multimeter to test the voltage and continuity of circuits. This can help you troubleshoot problems and ensure that the electrical system is working properly. If you are not sure how to do something, ask for help from a qualified electrician. It is always better to be safe than sorry. Before starting any electrical work, obtain the necessary permits from your local building department. This will ensure that the work is done in accordance with local codes and regulations. When working with electrical wiring, always follow the National Electrical Code, or NEC. The NEC provides detailed requirements for electrical installations. Consider attending a training course on electrical safety. This will help you learn about the hazards of electricity and how to work safely with electrical equipment. Always be aware of your surroundings when working with electricity. Avoid contact with water or other conductive materials. If you are working in a damp or wet environment, use a ground fault circuit interrupter, or GFCI, to protect yourself from electric shock. Never work on electrical equipment while you are tired or under the influence of drugs or alcohol. If you have any doubts about your ability to do the work safely, hire a qualified electrician. When disconnecting old wiring, label the wires so that you can easily identify them when you reconnect them. Use wire labels or a permanent marker to label the wires. Take photos of the wiring before you disconnect it. This will help you remember how the wiring was connected. When running new wiring, use cable staples to secure the wiring to the studs or joists. Space the cable staples according to the NEC requirements. When installing receptacles, use a level to ensure that the receptacles are installed straight. When installing light fixtures, use a stud finder to locate the studs in the wall or ceiling. This will help you ensure that the light fixture is securely mounted. When working with electrical boxes, use the correct size and type of electrical box for the application. Use a box fill calculation to determine the maximum number of wires that can be installed in an electrical box. When installing electrical conduit, use the correct size and type of conduit for the application. Use conduit fittings that are approved for use with the conduit. When bending electrical conduit, use a conduit bender to avoid kinking the conduit. When pulling wires through conduit, use wire pulling lubricant to reduce friction. When terminating wires at electrical panels, use the correct size and type of lugs for the wire size. Torque the lugs to the manufacturer's specifications. When installing ground wires, use green insulated wire. Connect the ground wire to the grounding terminal in the electrical box and to the grounding bus bar in the electrical panel. When installing arc fault circuit interrupters, or SIs, follow the manufacturer's instructions. SIs are designed to protect against arc faults, which can cause fires. When installing ground fault circuit interrupters, or GFCIs, follow the manufacturer's instructions. GFCIs are designed to protect against electric shock. Test the GFCIs regularly to ensure that they are working properly. When installing surge protectors, follow the manufacturer's instructions. Surge protectors are designed to protect electronic equipment from voltage surges. After completing any electrical work, inspect the work carefully to ensure that it is done correctly. Test all circuits and devices to ensure that they are working properly. Clean up the work area and dispose of any waste materials properly. Keep a record of the electrical work that you have done. This will be helpful for future reference. Consult with other electricians or contractors to get their input on time estimates and best practices. Collaboration can lead to more accurate estimations and efficient work methods. Consider the specific types of tools and equipment you have available. Having the right tools can significantly speed up the process. Power tools, specialized wire strippers, and other equipment can reduce the time required for certain tasks. Evaluate the complexity of the wiring. Older wiring systems may present challenges due to brittle insulation, corroded connections, or non-standard wiring practices. These factors can increase the time required to complete the work. Factor in time for troubleshooting. Unexpected problems can arise during electrical work, such as damaged wires, faulty devices, or incorrect wiring. Having a plan for troubleshooting and resolving these issues can help minimize delays. Consider the accessibility of the work area. Working in confined spaces or difficult-to-reach areas can slow down the process. Ensure that you have adequate access to the work area and that you can move around safely. Factor in time for cleanup and disposal of materials. Removing old wiring, packaging, and other debris can take time. Dispose of materials properly according to local regulations. If you are working on a large project, consider breaking it down into smaller, more manageable tasks. This can help you stay organized and avoid feeling overwhelmed. Set realistic goals for each task and track your progress. This can help you stay motivated and on schedule. Communicate with the homeowner or client regularly to keep them informed of your progress. This can help build trust and avoid misunderstandings. Be prepared to adapt your plan as needed. Unexpected challenges may arise, and you may need to adjust your approach to complete the work efficiently. Continuously evaluate your performance and identify areas for improvement. This can help you become more efficient and effective over time. Invest in training and education to stay up to date on the latest electrical codes and best practices. This can help you improve your skills and knowledge and provide better service to your customers. Consider the time of year when planning outdoor electrical work. Extreme temperatures, rain, or snow can affect the time required to complete the work. When working outdoors, be aware of potential hazards such as overhead power lines, buried utilities, and wildlife. Take precautions to protect yourself from these hazards. When working with electrical equipment, use a lockout/tagout procedure to prevent accidental energization. This involves disconnecting the power source and attaching a lock and tag to the disconnect switch to prevent it from being turned on. Never bypass safety devices or procedures. These devices are designed to protect you from electrical shock and other hazards. If you are not sure how to do something safely, ask for help from a qualified electrician. It is always better to be safe than sorry. When working with electricity, remember that safety is always the top priority. Take your time, follow the proper procedures, and use the right equipment. By doing so, you can help ensure that you complete the work safely and efficiently. In addition to these tips, there are a number of resources available to help you improve your time estimating skills. These resources include books, articles, online courses, and training programs. By taking advantage of these resources, you can learn how to estimate electrical work more accurately and efficiently. One important factor to consider is the specific requirements of the electrical code. The NEC provides detailed requirements for electrical installations, and it is important to be familiar with these requirements when estimating electrical work. The NEC also includes tables and charts that can be used to determine the correct wire size, conduit size, and other factors. Another important factor to consider is the type of electrical system you are working on. Different types of electrical systems have different requirements, and it is important to be familiar with these requirements when estimating electrical work. For example, a residential electrical system will have different requirements than a commercial electrical system. It is also important to consider the age of the electrical system. Older electrical systems may have outdated wiring or components that need to be replaced. This can add time and cost to the project. When estimating electrical work, it is important to be thorough and accurate. Make sure to account for all of the materials, labor, and other costs associated with the project. It is also important to factor in a contingency for unexpected problems or delays. By being thorough and accurate, you can help ensure that your estimates are realistic and that you will be able to complete the project on time and within budget. Remember to always prioritize safety and follow all applicable codes and regulations when performing electrical work. If you are not comfortable performing the work yourself, it is always best to hire a qualified electrician. It's crucial to remember that electrical work carries inherent risks, and mistakes can lead to serious injuries, fires, or even fatalities. Always double-check your work and test the circuits to ensure they are functioning correctly before energizing the system. When testing circuits, use a properly rated voltage tester and follow all safety precautions. Never assume that a circuit is de-energized until you have verified it with a voltage tester. If you encounter any problems or have any doubts about your ability to complete the work safely, stop and consult with a qualified electrician. Electrical work is not a do-it-yourself project for amateurs. It requires specialized knowledge, skills, and tools. By hiring a qualified electrician, you can ensure that the work is done safely and correctly, and you can have peace of mind knowing that your electrical system is in good hands. In summary, accurately estimating time for electrical work requires a thorough understanding of the tasks involved, potential challenges, and applicable codes and regulations. By considering all of these factors and using the tips and resources provided, you can improve your time estimating skills and ensure that you complete your electrical project safely and efficiently. Also note that the voltage drop also matters when the length of the wire run is significant. For example, if you are running a 120-volt circuit over a long distance, the voltage drop can be significant. The NEC recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders. You can use a voltage drop calculator to determine the voltage drop for a given circuit. The voltage drop depends on the wire size, the current, and the length of the wire run. If the voltage drop is too high, you will need to increase the wire size or shorten the wire run. Also consider directing the conductors based on the number of current carrying conductors in a raceway, cable or earth. According to NEC Table 310.15 column, the ampacity of conductors shall be adjusted where more than 3 current carrying conductors are installed in a raceway, cable or earth.